Hi Year 12, this is the solutions to the 2020 Maths Extension 2 HSC paper. We'll start with the multiple choice. Question 1. What is the length of the vector negative I plus 18j minus 6k? So recall, we want just the coefficients here and we want to square them. So negative 1 all squared plus 18 squared plus negative 6 all squared, which is the square root of 1 plus 324 plus 36, which is the square root of 361, which is 19. So the answer is B. Question 2. Given that z is equal to 3 plus I is a root of this equation, p and q are real, what are the values of p and q? So we've got real coefficients here, which means that the roots of the equation are going to be 3 plus I and 3 minus I. Now, the sum of the roots is equal to 6, and the product of the roots is equal to 3 plus I and then multiplied by 3 minus I, which is 9 plus 1 is 10. So remember, the sum of the roots is equal to negative b on a, and we know a is 1. So b is equal to negative 6, and the product of the roots is equal to c on a. Again, a is 1, and so c is equal to 10. So b in this case is p, and c is q. So p is negative 6, q is 10. The answer is B. Question 3. What is the Cartesian equation of the line this? All right, so we'll start with x is equal to 1 minus 2 lambda, and y is going to be equal to 3 plus lambda times 4. Now we need to make lambda the subject, so 2 lambda is equal to 1 minus x. Lambda is equal to 1 minus x over 2, and substituted in here, y is equal to 3 plus 4 lots of 1 minus x on 2, which is equal to 3 plus 2 minus 2x equals negative 2x plus 5. Wow, what a funny way to write all of these. We've put y first, so y plus 2x is equal to 5. The answer is C. Question 4. The diagram shows the complex number z on the Argand diagram. Which of the following diagrams best shows the position of z squared divided by the modulus of z? Okay, so if we're going to have z squared, let's just say that z is equal to r cis theta. Then it's going to be equal to r squared cis 2 theta, and this here is r. So this is going to be equal to r cis 2 theta. So it's going to have the same length. So that's going to knock out C and B. And we want double the angle. Now we've got an angle approximately, I don't know, 30 degrees there. So doubling the angle should bring it up here. So our answer is A. Question 5. A particle undergoing simple harmonic motion has a maximum acceleration of 6 meters per second squared and a maximum velocity of 4 meters per second. What is the period of the motion? Now we know the period of the motion is equal to 2 pi on n. We're going to use these two formulas. Acceleration is equal to minus n squared x, and velocity squared is equal to n squared a squared minus x squared. Now let's draw a quick diagram. I'm going to call the centre of the motion 0 because it doesn't really matter and 0 is easiest. Out here we've got the extremities of the motion, a is amplitude. Now at the centre of the motion, velocity is maximum. So velocity here is equal to 4. And at the negative extremity we have maximum acceleration. So acceleration here is equal to 6. Now it's just simultaneous equations. Substituting into number 1, we get 6 is equal to negative n squared times negative a, which is a n squared. Let's make a the subject because I want to eliminate it. And from number 2, substituting in the 4, we get 16 is equal to n squared. A squared minus 0 is a squared. Okay, substituting in, we get n squared. 6 on n squared all squared. which is n squared times 36 on n to the power of 4, which gives us 36 on n squared. And so n squared will equal 36 over 16. We don't need to worry about plus or minus because n is positive. N will equal 6 on 4, which is 3 on 2. And substituting in here, we get 2 pi divided by 3 on 2, which is 4 pi on 3. The answer is D. Question 6. Which expression is equal to the integral of 1 over x squared plus 4x plus 10 dx? So we're going to complete the square. So this is the same as 1 over x squared plus 4x plus 4 plus 6, which is the same as 1 over x plus 2 all squared plus 6 dx, which is an inverse tan. So we've got inverse tan of x plus 2 over the square root of 6, and then we're going to have 1 over the square root of 6 plus c. And the answer is A. Question 7. Consider the proposition if 2 to the power of n minus 1 is not prime, then n is not prime. Given that each of the following statements is true, which statement disproves the proposition? So we're looking for something that is not prime and then n ends up being prime. Does that make sense? So this one's not going to cut it because we're looking for something that is not prime. This one is not prime and this one is not prime. So it's either going to be B or D. Now we want n being prime, which is the power here. And it's not B, is it? It's going to be D. Question 8. If n is even, then if n is a multiple of 3, then n is a multiple of 6. This is poorly worded, this question, and done probably deliberately to trick you. This is all the premise here. If n is even, and then if n is a multiple of 3. This implies this. So to do the negation, we need this to be the same, and then we need the negation of this conclusion. So n is not a multiple of 6. So let's go through them. N is odd, and n is, no, it's not A. They've negated the premise. B, n is even, and n is a multiple of 3, but not multiple of 6. Yes, it's B. Question 9. What is the maximum value of this? And theta is in between and including 0 and 2 pi. All right, we know our complex number has got magnitude of 1. And so if we just draw a Argand diagram, we know that this is negative 2 here, and this is positive 2. Then Z is going to lie on a unit circle somewhere or other. And this part here means the distance that Z is from 2, and this one means the distance that Z is from negative 2. So the maximum that could be, like if you think about Z could be here, it could be here, here. It's either going to be at that point there or that point there. And so we want to know this length here plus this length here. That's 2, that's 1. So this is root 5, and this is root 5. Maximum distance is 2 root 5. The answer is C. Question 10. Which of the following is equal to the integral between 0 and 2a of f of x dx? Now, one of the ways you can do this question is just to make a suitable substitution for f of x and then eliminate, because you're not trying to do an actual proof here, you're just trying to eliminate the options. But let's have a look at how we do it formally. I'm going to start by looking at a and b, and I can see this is common to both of them. So we're going to make a substitution for this function. So I'm looking at this. And we say let u equal to a minus x. And so du is equal to negative dx. And the limits, when x is equal to 0, u is equal to 2a, and when x is equal to a, u is equal to a. So this guy becomes integral between 2a and a, and you can see that that is upside down, f of u times negative du. So I'm going to put the negative out there, du. Now I can turn this upside down and negate it. So it's going to be equal to positive a up to 2a of f of u du. Now, having it in terms of u is no use to me, so now I'm going to make another substitution and let x equal u, and everything's going to stay the same. So this is equal to a up to 2a of f of x dx. Okay, let's come across to have a look at these. So if with a, we have got the integral between 0 and a of f of x dx minus the integral between a and 2a of f of x dx, which is no use to me. It's not equal to that, so a is out. Now let's have a look at b. We have got integral between 0 and a of f of x dx plus the integral between a and 2a of f of x dx, and that of course is equal to the integral between 0 and 2a of f of x dx, isn't it? So the answer is B. Okay, that's it for the multiple choice. Our next video will cover questions 11 to 13.